how to use your calculator to find the maximum, minimum x-intercepts. And the first thing you want to do is actually put your equation into your calculator. So turn the calculator on, go to the y equals, and from there you're going to just type the equation in. Make sure of a couple of things. If the first number is negative, you can't use a minus key, you have to use a negative. And when you type the x squared key, that only puts the square, so you have to put an x first, then the x squared. That takes care of getting the equation in there. If when you graph it, by the way, I started with number 2 because it does something a little bit different here. When you graph it, it looks like part of the equation's missing. If that's the case, then you want to first go back and double check your equation. Make sure that you have typed it in right. And so we'll just go back, y equals, everything's there. I have an x and it's squared. I have an x and a constant term. It matches what they gave me. So what I'm going to do next is go to the zoom key, and I want to expand. I want to open that up a little bit. So I'll go down to zoom out. When you press that, it just takes you back to the screen. You have to press enter again to have it zoom out and show, actually expand. So now I can see everything except on mine, the very, very bottom is cut off, so I can't actually see that minimum point, but I know it's there and I can see where it's turning. So the first thing on our list is you want to determine if it's a maximum or a minimum, and I already pointed out from the graph, but we could do that without even graphing it. We know that the x squared being positive tells us that it's a minimum, right? So that vertex is going to be at a minimum value, a low point. When I go look at that then, I am going to go second, trace, and that pulls this big list of stuff up. I'm either going to do a minimum or a maximum to find the vertex. Since we said minimum, we'll hit the minimum key. You can just press the number if you want, and you're going to go to the left side of that vertex. Right now I'm up on the right side, so just watch that cursor. There it comes, and it's asking you, it tells you exactly what it wants. It wants the left bound or the left side, and you want to be as close to the vertex as you can. So I'm going to take it down to the very bottom of my screen. I could go a little bit lower and watch the y values, just make sure I don't go to the very bottom, but you're okay if you can see what's going on. Press enter, and now it wants the right side, so I'm just going back to the right, and I will keep doing that until it comes just visible on my screen. Right here you can see the little flashing. So press enter. The next thing it asks is, do you want me to guess? So once you set that left side and right side, and notice this particular calculator puts vertical lines, yours may do that, but it will at least put a little arrow saying that the minimum value should be between these 2 points. Then you're just going to press enter to have it guess, and it gives you the minimum value, the x and the y coordinate. So we're just going to go and write that down. Round, remember, to 3 places. So our minimum for this one will be a negative 9.926 when we round appropriately, and a negative 42.432 for the y coordinate. X-intercepts are exactly the same, except when you go to second trace, I don't see a key for x-intercept, but remember, x-intercepts, solutions, roots, and zeros are all the same thing. So I can go to zeros, and it's going to ask me to go to the left side and to the right side. I do have 2 x-intercepts, so I'm going to have to box in both the left and the right of one x-intercept, and then I'll do it again for the other one. So take your cursor to the left side, and if you notice on this left x-intercept, the left side is going to be above the x-axis. I have to be on the positive side of the x-axis at one point, and the other number has to be on the negative. When I go over here, the left side will be the negative part and the right side will be the positive part. So I'm going to press enter for my left and then go down, just making sure that you have negative y values. Press enter and then yes, tell it to guess, just like we did before. And sometimes it will not give you a 0 here. It gives you E, which remember that's scientific notation. And so that's really 0.000000001 out there somewhere with 11 places. It's sufficient enough to be a 0. So for our x-intercept then, we're going to have negative 21.098 comma 0 because it's an x-intercept. And if you go do the same thing on the right side, you can try this on your own, but you should get 1.2450. The only thing is the y-intercept is not a feature on here. When you look at second trace, there is nothing to find the y-intercept. So we're going to have to do that on our own, but remember that's just plugging 0 in for the x, and since it's in standard form, when I do that, this becomes 0, this becomes 0, so I just get negative 8.93 as the y-coordinate of the y-intercept. Domain and range are just like we've been doing. That's not going to come from the calculator. This is a parabola, so we know that our domain is all real, which again, remember, is negative infinity to positive infinity, and infinities always get parentheses. Range this is a minimum, so we know it's this shape. It has a starting point and goes to infinity. So it will start at, range is the y's, so it'll start at that negative 42.432 of the vertex and continue forever. Parentheses again because that's infinity. There is a point here, so that will get a bracket. Alright, so take a second, go stop the video, go try number 1, and I'm going to give you the answers for that one. Here are your answers for number 1. If you're not getting these, make sure that you come to see me during drop time or you ask about them during class tomorrow. You can stop the video if you need to look through the answers a little bit longer. We're going to move on to example 4. And on that one, to example 3. And on this one, this one's just a regression. So we're going to put this data into our calculator just like we did for linear problems. So that, remember, is stat, edit, and type your left and your x's and your y's into the 2 columns. If you want to follow along, stop the video for a moment and do that. Once you've got the data in, we're going to go second y equals to get to the stat plot, and one of these needs to be turned on. So I'll press enter on the on, and then we're good to go. Just make sure it does have a scatter plot, and we can then go zoom 9. 9 is stats, and it should pull up your stat plot, your scatter plot. When you do that, we just want you to make a general little sketch of what that looks like. And this one was very much quadratic, if you look at it, right? There's a few little points that overlap a little bit, but for the most part, it's very much quadratic. So what type of regression model do you think? I think we're going to use a quadratic on this one. All right? They want us to create that regression model. So we're going to do that with the calculator by going back to Stat, Calc, and since we think it's quadratic, that's choice 5. Enter. And you can store that. Remember to do that just like with linear. You press the bars, y bars function, and just choose one of those, and then go calculate. When you do that, it gives you the A value to put with the x squared, the B value to put with the x, and the C value to put at the end. And it will, if your diagnostics are on, give you an R squared value. So our equation, and again, remember, a model is an equation, so it has to say f of x or y equals, and that should have been negative 0.008 x squared plus 7.739x plus 13.592. And then it asks for our R squared value, which is 0.0068, so that'll be 007. I'm not sure what I had. Oh, that was my linear R squared. The R squared for our quadratic, this one was linear. Obviously not very close to 1, so we know it's probably not linear. R squared for the quadratic wound up being 0.978, very close to 1. So definitely it looks like it is going to be quadratic. They want us to make the predictions for the maximum number of gallons. So those predictions, remember, since we saved the model, that VARS key there, we can simply go back, looking for my calculator in the wrong spot, sorry. We can go to the calculator, and they want us to estimate the maximum number of miles per gallon. So I'm going to actually find my maximum, second trace maximum, and it'll plot that equation for me. And I can just come back to the left of that a little bit, and I'm going to choose a point there. As soon as it stops, probably a little far to the left, but we'll go to the right. Give it a second, let it stop there. And we'll choose that value and have it guess the maximum, which it's going to give you an x and a y value. And that x and y value for the maximum wound up being 45.417 and 30.384. Remember, this is your x, this is your y. Our x up here represented speed, and the y represents gas mileage. So this is our speed, our maximum speed, and this is our maximum gas mileage. So when they ask us to predict the maximum number of miles per gallon, that's going to be the 30.384 miles per gallon. When they want to know what speed will produce that maximum, then that's going to be 45.417, and I believe that was miles per hour if you read. And the last thing, they want us to estimate the miles per gallon that you would get at 55 miles. We're simply going to go to the table, second graph, that pulls up your table. And if you're nowhere near 55, then what you can do is go second window, table set, and just tell it where you want to start. So I've got 55 in there, so when I go to table, it takes me to 55 automatically, and that's going to give me 29.637 miles per gallon. Again, this is an estimate, but it should be somewhere in that neighborhood. Stop the video and try number 4, and I'll give you those answers. Here's the answers to number 4. This one wasn't as definite a quadratic look, but it does appear to be. I've got the regression equation, I've got our R squared values, and I've got 2 different predictions here for you. So take a look, see what you can do with those, and come to class with your questions. Thanks.